Hello, hello. Today we are looking at solving systems by elimination, but now something weird's going to happen. All right. So you guys already know how to solve systems. We've been practicing it for a couple different days, sort of some different things that are coming up. So something weird's going to happen on these, and then we'll talk about those. So if I go ahead to start number one, just like always, I want to make sure that they're in the same order, but they are. X, Y equals some number. They're both good to go. Then I want to look and see if I have a pair of opposites. Hey, check it out. I do have a pair of opposites. I have a negative 6x and a positive 6x. So even better, because now I don't have to multiply by anything. Let's go. So let's go ahead and add those together and see what happens. But for some reason, it's not showing up on my screen here. Oh, there it is. Okay, just a little delay. So let's add negative 6x plus 6x. Well, that goes away, right? It just cancels out. So let's just keep going. Oh, but look, a positive 4y and a negative 4y, that also cancels out. So what's left on the left-hand side? Nothing, 0. And what is that equal to? Well, I'm still going to add on the right-hand side. Negative 4 plus 4 is also 0. So I'm left with 0 equals 0. Do you remember what that means? When everything has canceled out, but you are left with a true statement. It is true, 0 does equal 0, but everything's gone. There's no x's or y's for me to solve for anymore. Hopefully you are thinking about this and you're remembering, oh yeah, if I have a true statement but everything's gone, that means it's infinite solutions. And that's your answer. Why is this infinite solutions? This is because, again, if you were to rewrite those two original equations in slope-intercept form, you would see that they are literally the exact same line. So the top line maybe looks like that, and then the bottom line, whoops, is right on top of it. Like they literally are the same line. So there are an infinite number of solutions, meeting points, right? Points where they overlap. But remember, we want to steer clear from saying all real numbers, because that's not true at all. Every single number is not a solution to this system, but there are an endless number of answers. Okay, so I hope that that you remember that. If I'm left with an equation, everything else is canceled out, but it's true. It's a true statement. 0 does equal 0. Or it doesn't have to be zeros. It could be 5 equals 5. It could be 19 equals 19. As long as it is a true statement and everything canceled out, infinite solutions. Okay, let's go ahead and take a look at the second one. Okay, second one. Hey, lucky us. Again, it's already, I already have a pair of opposites. 9x and a negative 9x already cancel out, so I don't even have to do anything besides add these two together. So the x's cancel. Okay, weird, the y's cancel again, so what's left on my left-hand side is 0. But now on the right-hand side, negative 6 plus 7 is 1. Does 0 equal 1? Hopefully you're saying, of course not. That is not true. So what does that mean when you get a bogus solution, something like that, that's not a true statement? Hopefully you are thinking in your head, no solution. And can you tell me why? What is going on with these two lines? Did you say they are parallel? I hope so. Remember, parallel lines are the ones that are not going to have a solution because they never cross. So how could I get a solution point? One curves, right? So no solution, and that's when I get a bogus solution like that. It doesn't make any sense, but everything did cancel out. Let's take a look at number 3. Okay, so again, this one is, we keep getting lucky here. I already have a pair of opposites, so let's go ahead and add them together. So the x's are going to cancel. This time the y's do not cancel, right? 6y plus 7y gets me 13y. Negative 18 and negative 21 are going to add together to get me a negative 39. And then I can divide both sides by 13. And looks like y is going to be a negative 3. Okay, so now let's go ahead and take that value, and how do I find x? Well, you're going to go back to one of the originals, remember? Let me just erase crossing that out since I need these again. Go back to one of the originals, it doesn't even matter which one, and plug in negative 3. So I'll take the top equation. So 4x plus 6 times, now I know that y is negative 3 equals negative 18, and let's go ahead and solve. 4x minus 18 equals negative 18. Add 18 to both sides. 4x equals 0. I know you might be thinking, okay, well, that's something weird, but it's not. You can get 0. It's no big deal. Keep solving. Divide both sides by 4. What is 0 divided by 4? It's just 0. So I kind of tried to trick you on this one. This one didn't have something weird happening. They're not parallel. They're not the exact same line on top of each other. These are just two lines that happen to cross at the point 0, negative 3. Okay, so don't assume that all of your answers on this sheet are just going to be no solution or infinite solutions, because that's not true. I threw in just some regular ones, kind of throw you off. So make sure that you're paying attention. Make sure that everything kind of does what you expect it to do. So let's take a look at the last one we're going to do together, number 4. Okay, so I'm looking. I do already have a pair of opposites with the x's and with the y's, so that's interesting. See how that plays out. So we'll go ahead and add these together. The x's are going to cancel. The y's are going to cancel. So what's left on the left-hand side? Just a 0. But what's on the right? Negative 18 plus 8 leaves me with a negative 10. So all my variables cancel out, but I'm left with a statement that makes no sense. So what does that mean? That means I have no solution. And why do I have no solution? What do these lines look like? You're right, they're parallel. Okay, so that's all there is to it. You try the rest. Let me know if you have problems.